Alright, continuing reading chapter 6. We are on Introduction to Cathodic Protection Inspection Testing. Alright, 6.11.1, your 4-pin method. The most commonly used method of measuring soil residue with the 4-pin method. The current is passed with the two electrodes, dropping the potential through the soil. The duty of the passage of the current is measured with a second pair of electrodes. Specialized instrument used to supply with the current potential of the potential drop to reduce the influence of any stray currents in the area. The instrument supplied with the alternating current range of the electrodes shown in Figure 26. Figure 26 shows soil relativity 4-pin method. The cathodic protection pins, potential pins, and current pins. D is your pin spacing depth of the reading, current flow. The soil resistivity is calculated indicating the reading by using the following formula. The resistivity ohm is equal minus the centimeters equal to 191.5 times pin spacing and feet times meter reading. Alright, in this method, the average resistivity is soil between two electrodes due to the depth of equal to pin spacing. Measure the pin spacing, increase within the average soil with the resistivity greater depth of the measure of the average resistivity, increase with the pin spacing, increase with the region with the higher soil resistivity at the depth of the average soil resistivity. To decrease the depth, there is the region. Lower resistivity of the depth of multiply with a common distance for even multipliers. Table 2, Table 3 show the 4-pin soil resistivity measurement reading multipliers, common distances, distance between the rods, multipliers, distance between the rods, multiplier, even multipliers. So you have 6.11.2 2-pin method. In the 2-pin method, the soil resistivity measurement of the potential drop measured between the same pair of electrodes used to supply with the current. The equipment of used to make with the type of the measurement, often called the shepherd's cane, after its inventor, is shown in the figure 27. The probes with placed 0.3 meters and 1 foot apart with the soil with the 2 hard with the probes to penetrate with the reading. Taken from the bottom of the 2 augured hole with the measurement is calibrated with the probe with the space within 1 foot. Give the reading of the direction of the ohm and the centimeter. Although the method is accurate for the 4-pin method, less accurate than the 4-pin method, the measure is relatively of the soil one only near the survey. They often use the preliminary survey quicker than the 4-pin method. Alright, figure 27 shows the 2-pin method. The shepherd's cane, the soil resistivity of the auger hills if required. D 1 foot spacing, instrument depth of the desired 2-3 feet. 6.11.3 other methods of soil rod, soil box. The soil rod is essential for the 2-pin resistivity measuring device for the electrodes. Both require with a single rod shown in figure 28. As other 2-pin method, the resistivity of the soil is very shallow depth is measured. All the soil must be soft enough to allow penetration of the rod. Measurement of the soil rod, however, that can be taken quickly when measuring soft soil. Figure 28 shows soil resistivity measuring soil rod. Metal tip installed with the rod shank, 2-inch rod, steel shank, terminal connected by wire inside the shank with the metal tip, the terminal connected with the metal tip. Contact terminals AC resistant measurement. When impractical to make the field measurement, soil resistivity soil boxes taken from the resistivity of the sample determine the using a soil box is shown in figure 29. Method of measurement essential 4-pin method. Metal contacts on each end of the box pass through the current and through the sample. Potential drop is measured across the probe is inserted with the soil with the resistivity is calculated U of the contact of the furnace for the particular side with the soil box being U of the disturbance. The soil during sample the possible drying out with the soil during the shipment method of the soil. The resistivity measurement is likely to represent with the true in place soil resistivity that actual field test. To minimize drying out of the sample, they should be placed in plastic bag sealed prior to shipment. Figure 29 shows soil resistivity using a soil box. 6.12 pH testing procedure. pH electrolyte measurement of the acidity alkaline electrical solution. pH ranges from 0 to 14, 0 to 7 being acidic, 7 being neutral, 7 to 14 being alkaline. pH can be measured supplement for the pH electrolyte with the state of the active acidity of the alkalinity as a major factor for determining the rate with which the metals corrode. As solutions have more hydrogen ions than hydroxyl ions, the electrolyte pH is tested playing with the design conservation leak survey for steel corrosion remains fairly constant with a pH of about 4.5, the pH of about 10.5, with the pH between 4, and the corrosion from a rate with the steel is drastically accelerated. Also, the pH of 11, the corrosion rate for the steel is drastically lower, except for sharp range of the pH approaches 14 now shown with the figure 1030. For aluminum, acidic corroded rates are similar to steel, but unlike iron, steel, and aluminum showed with the accelerated corrosion attack and alkaline electrolytes above pH at 8.5 because of the reaction with aluminum ions, positive ions, and hydroxyl ions, aftermatic. Alright, figure 30 shows the inches per layer, and then the figure over the electrolyte pH, figure 30 effective pH on corrosion. 612.1 autonomy electrode tested method. The autonomy unique method with character of the direct relation of pH for the measure potential for the potential difference of voltage developed between the autonomy copper sulfide reference electrode varies approximately 0.1 volt DC to 0.7 volt DC due to variation in pH. Consequently, it can be used to determine the pH electrolyte when used together with the reference electrode. The autonomy electrode must be cleaned prior to use of the copper sulfide electrode. Special cleaning procedures must be used cleaning the autonomy electrode as per instruction 6211A. Autonomy is very brittle. Treatment is careful with the autonomy tip. Must be kept smooth and there must be no rough surfaces or pits. Show the autonomy electrode bottom, body top connection, voltage, pH scale, autonomy electrode. Place the autonomy electrode with a copper sulfate half cell with contact with electrolyte. Measure the potential difference of the high inputs for voltmeter. The measure taken several seconds with these stabilized. Stabilization is more solid than acid solution. Alkaline solutions avoid taking the measurement with a cathodic direction current. Current flow with electrolyte will affect the accuracy of the current flow. Can be stopped. Place with the two electrodes close together. Perpendicular direct current flow. To measure the presence of any of the current electrolyte, place one with a copper sulfate half cell. Second copper sulfate half cell. A few inches apart with the contact electrolyte. Measure the potential difference with the high input resistant voltmeter to make sure the several directions and no current present. The measure will read if the current is present. The lowest measurement will be the least amount of the current is flowing out. Also, with no current flowing electrolyte measure taken should be the same as the measurement taking place on the two cell tip to tip with the touching electrode. Alright, show the figure 32 show the pH and electrolyte current flow. Incorrect current flow. Correct flow recommended. Up and down is the correct current flow recommended. Alright, 612.2 chemical test method. The chemical test method usually associated with liquid electrolyte, same with the chemical method of measuring pH involved with either the use of the pH measuring electrode indicate with the rose color depending on the pH measurement of the difference between potential pH and sensitive to the reference electrode whose potential is sensitive to pH. The color indicators are normally used to form pH papers. Paper is weighted with the solution being measured with the result in coppered compared with the color standard with the determine the pH of the chemical meters indicate with the using the pH of the soil following the procedure. Use a small amount of the soil, one of the 2 tablespoons placed in the cleaning of the container with the equal amount of the water. After stringing the mixture is allowed to so the pH is liquid and simple is measured. 613 calibration of the Ampere Armor drop test band. Ampere Armor drop test band. Tip of the cathodic progression test station valve 2 for determination of the direction. Magnitude of the DC current flow through the pipeline. Predicted pipelines information can be used with the vary current distribution. Look for the tray interfering with the currents or areas of influence. Install rectifiers on predicted pipelines. This information can be used with the finding ionic areas and void and find discharge. Pick up the area with the tray current interference currents. Measure for the metallic piping and cable as shown with the caliper rated the U the measure for the millivolt air armor drop, which current will be calculated with the known as the DC current that is applied with the pipeline voltage drop. The curve of the length of the measure for the air resistance estimated on the side of the pipe with the distance of the test plan. Currently known with the line current with the be determined the null meter. Ammeter method, multi-combination meter, one with the method to determine the direction and magnitude of the DC current flowing through the pipeline clamp. Milliammeter method requires a very specialized piece of equipment, size to the pipeline, excavating access of the pipeline, the placement, probe around the pipeline. Or the preferred method to measure actual resistance of the pipe. Use the test current of the method does not require the knowledge pipeline size of the wall thickness, but is not affected with the variation metal due to the composition of the corrosion variation resistant due to temperature. Inaccurate length of the test band with the amount of the test current will require the dependent with the diameter of the pipe with the distance of the test band with the larger the pipeline, the larger amount of the current required. The shorter the distance of the test band, the larger amount of the current required. Show the voltmeter in figure 2, the amperometer drop test band. Test station, voltmeter, pipeline cable. Caution. Use an ohm meter to measure the resistance of the pipeline cable. The current flowing with the pipeline cable through the meter damage could the result of the current damage does not damage the meter. The measurement would indicate that the resistance value of the voltage should be interpreted by the voltmeter coming from the internal body instead of the external electrical circuit being measured. Figure 34, calibration ampere drop test station, ammeter switches, DC power supply, adjustable resistor, voltmeter, ampere drop test station, pipeline cable. Alright, 613.1, measurement of the circuit with the calibration ampere with the drop test band involved with the two measurement circuits of the outside of the circuit comprised of the ammeter to measure for the current with the DC power supply on-off switch. Some of the means of adjustment the powerable rectifier may be with the current supply source switch or the means of adjustment inside of the circuit with a high input resistant voltmeter minimum 10 mega ohm meter set with a millivolt scale. Pipelines cables inherently will currently flow at all times though through a change of voltage drop measurement is compared to the amount of the test current applied following a polarity. Figure 34. Connection of all circuits. Components of the polarity is important for the correction during determination of the direction of the current flow of the pipeline cable during subsequent test procedures. With outside current shut off, record the millivolt amp measurement with the inside of the circuit. Starting a low current test outside circuit with a switch on and adjusting current of the desired test current with the required measurement of the test current. With outside circuit remaining on, record the millivolt measurement inside of the circuit. Apply this data to the following formula. Resistant is equal to voltage on minus voltage off over the test current applied. Your factor is your test current applied over the voltage change. Your record resistance with the test span with the calibration factor is established temperature of the pipeline with the cable that remains constant. Calibration can be potential with the amperometer drop test station used for future measurement of the diff stop. Exists temperature change to perform calibration steps in the time measurement as are taken. 613, direction current flow. Direction of the current is determined by the polarity of the millivolt reading from the inside of the current. For example, the figure 35, a positive IM op drop indicates current flowing from right to left, with the negative IM op drop would be indicating left to right. 613.3, resistance of the pipeline. Resistance of the pipeline can be calculated the distance of the test span known to the side of the pipeline and accurately known. Resistant joints insulators cannot be present on the pipeline in the testing span. The variation of the temperature will adversely affect the accuracy of the calculations. Your millivolt amp drop is measured using a voltmeter millivolt scale shown figure 35. Following on polarities figure 35 connecting the matter meter to the inside of the circuit with the record measurement of the polarity of the important with the correct determination of the direction of the current flow pipeline current cable during the subsequent testing procedures. Resistance estimated using table 3 with the resistance given the millionth of an ohm per linear foot on pipeline. Resistant value must be multiplied by the number of the feet with the test span. The distance of the feet of pipeline between the actual connection points of the test speed station leads to the pipeline. This shows the nominal pipeline size of the outside diameter, wall thickness, weight per foot, and resistance per foot. This data is applied with the following. The current is equal to millivolt ampere ohm drop over the resistance. The direction of the current is determined by the polarity of the millivolt ampere ohm drop. Reading measure, for example, 35 positive the ampere ohm drop indicates current from right to left. The negative ampere ohm drop will indicate the current from left to right. 613.4, multi-combination meter. Multi-combination meter with the capability of the measurement current by null ammeter of the meter can measure the line currently with the 2 amp, but do not use the method in area of the 2 amps of line current. State current variation fluctuation measurement may make with the keep of the meter null to obtain accurate, reliable measurement. It's difficult to measurement. Method does not require any information length with the test span diameter of the structure of the type of the metal being tested. Figure 36 shows the null ammeter method using multi-combination battery if required, outside circuit, inside circuit, millivolt pipeline, or cable multi-combination meter. 614, interference test procedure. When current flows through electrolyte valve with the path of the least of the electrolyte resistant metal structure is an immersed current carrying electrode likely to present local resistant path of the flow current. At the point of the electrons enter the structure for the electrolyte, corrosion will be accelerated. When electrons that leave the structure, corrosion will be reduced. The phenomenon is called cathodic interference. Cathodic interference is commonly encountered with the buried structures. Cathodic intrusion can be a detect electrical measurement that can be the control of the cathodic protection, sometimes called the undesirable effect of the structure not connected to the protection system. This occurs may some of the current is picked up with the foreign structures, such at one point, an attempt to return to the source completing the circuit is discharged through another. Corrosion occurs with the current discharge point, but the current can cause the corrosion damage passing 2 structures across a high resistant joint, and the same structure sources of the interference currents might be constant fluctuation. Constant current sources have essentially constant direction current, cathodic protection rectifier, thermoelectric generator. Fluctuating currents have the fluctuating direct current output, such as direct current electrified railway system, coal mine, haulage systems, pumps, welding, machine direct current power systems, right? Tolerant currents mitigation can be easily accomplished by installing an electrical bond between the unprotected structure, the location maximum discharge protected structure. Other mitigation methods include breaking continuity of the foreign pipeline, coating the foreign pipeline pickup area, current the protected pipeline with the discharge area foreign pipeline using galvanic anodes to apply with the current with the discharge of foreign pipeline. Also provide alternate discharge point. Alright, 614.1. Interference with the cathodic protection raft. Cathodic protection major surface with a straight rective current with a metal structure. Structures not electrically connected with the protected surface that are considered to be foreign structure. Foreign structure may provide alternate path with the current flowing with the impressed current anodes of the protected structure. If this path is sufficiently low, resistance, significant current flow will occur. Since there is no metallic return path, the current will discharge from the surface of the foreign structure to the electrolyte to return to its source, resulting in severe corrosion. Testing requires a cooperation by the owners, structures involved, such that the cooperation is best effective with the Corrosion Coordinate Committee. All companies operating underground, underwater structures, particularly with those of the Cathodic Protection, should be members of such committee. All existing committees may be detained by the National Association of Corrosion Engineers, P.O. Box 218340. Houston, Texas 772188340. Interference testing usually performed in new cathodic protection systems are first installed, sometimes detected with a routine field measurement. Record keeping is very useful preventing cathodic interference problems. Any of the chain with a particular addition of the new body structure can be easily determined by the proper records are kept. The interference test must be made on all structures deviating from the cathodic protection system. Determine effects, allow design mitigation measurements. Our cathodic interference detect meeting structure to soil potential gradients, current ampere drop flow, cathodic protection current resistant bonds and or cycled on off structure soil to potential given an indication of interference when only measured in an area current charge or pickup of the foreign structure, abnormal unusual current distribution or a protected structure indicate the possible interference on a foreign structure. Current flow, the ampere drop reading shows the relationship between the pickup of the discharge area with the foreign structure. Cathodic protection rectifier outputs the waveform which resolve with the pulsating DC signal. Presence of the pulsating DC signal foreign structures indicate the interference of the rectifier. Conducting current requirements test, initial energizing impressed current cathodic cathodic protection system. All companies owning an underground structure in the area with notified current nation testing made with those interested. Current drain requirements for the age structure of the test or various and/or locations can be determined. Our Bethmed located with the interference with the pipe at the soul of the potential survey of the foreign pipeline source of the interference cycle of the on and off, specifically the interval of the algebraic difference between on and off reading of the potential shift, the give of the interference effective of the foreign stroke of the location show of the greatest pipe to soul potential chain with the positive of the unprotected direction is called the critical or control point, often the point where protected and unprotected pipeline cross. There are showing pipe to soul potential chain with a negative direction called the pickup area. The presence of the pickup of the area of the foreign structure indicate the interference of the present discharge area exists somewhere on that structure. And metallic continuity exists between the foreign structure with a negative terminal rectifier. There's no interference with the protection, no discharge area, but there's a definite foreign structure. With the sources of the cathodic protection, cathodic interference is known. The detector the measuring structure soil potential cathodic protection current, but by measuring potential gradients, structure soil products potential give the indication of interference only when measured in area with the current discharge pick up on the foreign structure. Potential gradients are measured with the cell. The cell test procedure for taking these measurements are given along form and pipeline may locate with the discharge point and pick up the area of the polarity may be certain to determine the direction of flow, with the magnitude of the current will flow with the direction of the discharge point. The magnitude will increase as near the discharge point. Direction will reverse upon passing the discharge point. The reversal of the high magnitude with the control of the critical point. Discharge point is usually near the structure which caused the interference. The pickup area is usually near the anode system caused the interference. Locate the pickup area. Important is locating the source of the interference so it shows the direction of the current is coming from. Shows positive reading voltmeter reference to electrode 1 and 2. Current flow in the earth direction of the anode of the area on the pipeline. Measurement current ampere drop of the foreign pipeline accomplished with other methods inclusive of the current ampere reading shown with the relation between the pickup of the chain with the area of the foreign structure, the measuring current with the flow of the foreign structure, the direction of the discharge point, pickup area can be determined by the magnitude of the increase of the shear, the increase of the distance of the discharge point decreases. The measurement can easily be accomplished in an ampere drop test station already existing on the pipeline accessible comes above ground past the pits. Current measured ampere test station by procedure of the detailed current is measured with access to the pipeline possible with the clamp on ammeter such as the twin ACM Cathodic protection amp clip. The corrosion size clip, correct size clip must be used for the pipeline under test. So the typical clip meters that work on this in this application. It must be capable of measuring DC amps with a range capable of accurate measurement under 30 milliamps. Abnormal unusual current distribution on a protected structure indicates possible interference with the foreign structure. Normal, the potential of protected structure decreases slightly. Sensitive to the anoid direct increase of the defects of the coating of the detail of the protected structure decreases. Here's potential normally indicate with the current pick of the potential protected pipeline increase with the corrosion of foreign pipeline interference is likely on the structure. Potential services survey of the structure while interrupting the source of the current indicate with the present magnitude of the interference. Alright, you have figure 38, normal, abnormal, potential, protected foreign pipelines, potential survey, pipelines, interference, anoid bed, pickup area, discharge, foreign pipeline, normal, potential survey, above, potential survey, protected pipeline, potentials, abnormal, potential survey, foreign pipeline, potentials, normal, potential survey, abnormal, potential survey. Alright, Cathodic protection rectifier output contained with the waveform which resolve with the pulsating DC. The signal located with the pipe locator capable of 120 cycles per second. This is the pipe horn model 200 FTAC rectifier mode. Presence of the signal indicated with the present interference with the foreign structure. Find the method of the current interrupted suspected source of the interference. Quickly locate the source of the interference. Signal strength can be sometimes indicated with the direction of the discharge pickup areas. Normally, signal strength will increase the direction of the discharge point, but not occurring with the multi-discharge areas. Another method of interference testing using the experimental drain bond between structure proper drain with determine the trial and error. Use the variable resistance to alter the drain current with the required drain and current that can also be computed with the task tab of the stream of the owner. Maintain with protected structure with foreign structure methods may be easily used with the source of the interference cycled on all specific intervals of bond and resistance as you adjust the no potential shift the current with the foreign structure when it's like condition warm with the bond with the maybe side with that partial full protection foreign structure. The foreign structure is small, well coated. The protected structure is poorly coated. The option may be taken with a sufficient cathodic protection current. Still available to protection. Maintain protection on the protected structure. Alright, 614.2 with interference variable fluctuating surface. Well, the interference testing determines the effect of the steady of the trade currents, any other type of the trade currents, survey analysis, fluctuations, trade currents, fluctuation, periodic changes, structure, electrolyte, voltage, joule, unusual fluctuating currents indicative of straight currents. Straight currents may affect the structure, but the cathodic protection does. Structures may be protected of damage, straight currents, depending on whether currents flowing to or from the structure of such analysis specialized required for the type of the master of all techniques. The basic principle is the same in the previous paragraph. The difference is straight current is not present at all time. The simultaneous data log or recorder in devices have many points with the foreign structure and they give the same information as above. Locating discharge point pickup areas is still critical in case to determine the time of the interference is also crucial. All basic measurements can be either the second fluctuating straight point of currents, perhaps the most informative measurements similar to the interference testing is structure electrolyte potential, the ampere-ohm job along structure or electrolyte methods of analysis. However, the different specialized equipment is used. The measured concern with the performance straight current survey is to find out the degree of the damage, determine the source of the current measurement of the foreign pipe potential commonly used to determine the pickup of the discharge of the use of data loggers. Recorder device may location foreign structure monitored spontaneously. The data is charted to analyze the presence of interference with the exact moment of the interference to determine the potential reading with the taking the instant with the use to determine the discharge point and pickup points. Data taken with the location of the area taking additional data, other gathered data with exactly like the data with the cathode interference data. Detail abnormal potential of the other structures may also be used with the further analysis. Once the pickup area with the time of the determine the further time the source of the current may be located. Any other method of finding these points through the current measurement to determine the pickup of the discharge point with the fluctuating straight current area with the data with the several test points applied over the period of the time. The current value of several location foreign structure recorded at ampere-ohm drop test band, clamp on milliammeter, all plotted over the period of time of the current must be measured at several points simultaneously. Efficient reading being made over the cover range of the variation currently using 20 to 24 hours by analyzing current direction of the magnitude of the time of the interference of the current. The relation of the direction of the pickup of the air with the discharge area can be determined at one time the interference is known. The area of the pickup can be searched for the possible sources of the current pickup of the outside with the necessity side and simultaneous reading due to the fluctuation current of the method of the sine as the conventional line current measurements. And that was the last of it, and then it goes into testing for you PDH learners. And it's a 25 question test, so this was the second tape to the introduction of cathodic protection testing.